Hey everyone, in this video let's take a look at how we find all the asymptotes for a given function. There are two kinds of asymptotes we're going to take a look at, vertical and horizontal. So the first thing, let's talk about what these mean as it relates to limits. So first, a vertical asymptote. What we're going to be looking for initially with vertical asymptotes is any discontinuities in our graph. So let's say we have a discontinuity at some value, and we'll say c. So we notice we have a discontinuity at x equals c. Maybe it's something that's excluded from the domain of our function. What we need to do to find out if this is a vertical asymptote is we need to test the limit as we approach c from both sides. So we need to test the one-sided limits as x approaches c. So in notation, what we want to take a look at is we want to take a look at the limit as x approaches c from the left of f of x. And we also want to take a look at the limit as x approaches c from the right of our function. And as we test out these limits, what we're looking for to be a vertical asymptote is we want these to be infinite limits. So either approaches infinity or maybe it approaches negative infinity. So I'm going to write plus or minus infinity here. So as we get closer and closer to c, our function values are becoming unbounded. Now the second thing are horizontal asymptotes. So what we're going to be testing to find out if we have one of these is we want to take a look at our limits at infinity. So what we want to do in notation, we want to look at the limit as x approaches infinity of our function. And we want to take a look at the limit as x approaches negative infinity of the function. And what we're hoping for is that it approaches some number. So we want it to approach some constant. So I'm just going to write, we want this to be equal to k. And then I'll ping a note here where k is a constant. All right, so those are the two ways we need to check for asymptotes. We'll check for discontinuity, and then we'll check the limit as we approach that discontinuity. And then for horizontal, we want to check the limits at positive and negative infinity, basically checking the end behavior. So let's do that in an example. So here I'm given a function, f of x is equal to 2x plus 1 divided by x minus 2. Okay, first thing, let's take a look at the domain. So the domain here, the restrictions we have, we just don't want to divide by 0. So the one value of x that would make the denominator 0 is 2. So our domain is everything but 2. So we have from negative infinity to 2, and then union 2 to infinity. So we have this discontinuity at x equals 2. Okay, so first off, that's what we want to use to test for a vertical asymptote. So we need to test the limit as x approaches 2 from the left of our function. And we want to test the limit as x approaches 2 from the right of the function. Okay, so we can do this with a table of values if we want, or just reasoning through this. So as we're coming from the left, we're going to pick out values of x that are getting very, very close to 2. So maybe we pick out something like 1.999. Well, if I take a number very close to 2, but a little bit less than 2, and I subtract 2 from that, I'm going to end up with a number that is very small and also negative. So I end up with 2 times my number plus 1, and then this is going to be divided by a very small negative. Okay, so now if I'm dividing by something that's very, very tiny and negative, okay, dividing by a very small number is going to make this entire quotient, it's going to be a very big number. So what we end up with is this is going to approach negative infinity. So because I'm dividing by a very small number, this becomes unbounded in the negative direction. Okay, same idea for the second one. So now we're going to pick out values of x that are just slightly bigger than 2. So maybe we're going to look at 2.001, for example. Well, I have a number that's just slightly bigger than 2, and I subtract 2. What I end up with is I'm going to be dividing by a very small positive number. And following the same sort of logic, if I'm dividing by a very, very tiny positive number, this is going to become unbounded in that positive direction. So this is equal to positive infinity. And because my two one-sided limits are negative and positive infinity, that does mean we have a vertical asymptote at x equals 2. All right, so that takes care of the first thing. The second thing, for our horizontal asymptotes, we want to test out our limits at positive and negative infinity. So let's start with the limit as we approach positive infinity. 2x plus 1 over x minus 2. So we talked about a couple different methods we can use to try this out. One of those was just looking at our leading terms. So this is the same as the limit as x approaches positive infinity of our two leading terms for these two polynomials. And written like this, we can simplify. So the x's simplify and we end up with 2. And the limit of a constant is just the constant. And we can do the same thing for the limit as we approach negative infinity. So as we approach negative infinity, we can also just look at those two leading terms. So we get the limit as x approaches negative infinity of 2, which is also just 2. So that checks out. We want these to match, and because they approach this constant, we have a horizontal asymptote at the line y equals 2. Okay, so to summarize, we test out the one-sided limits wherever we have a discontinuity to check for vertical asymptotes, and we check out the limits at positive and negative infinity to check for horizontal. So all of these limits, these are what I would use to justify that these are in fact the asymptotes. And verifying that with the graph of this function, I can see that I have a vertical asymptote at x equals 2, and then the end behavior of this function, it does approach this line y equals 2.